In this episode, we're going to be talking about how to read bond line structures. So to start off with a bond line structure, let's look at these few organic compounds. Over here, we have a compound with 4 carbon atoms and 10 hydrogen atoms. So let's write that chemical formula, C4H10. And this is actually a pretty well-known compound. It's called butane. Now down here, we have 6 carbon atoms and 6 hydrogen atoms. So we're going to write that over here, say 6H6. And this is a compound known as benzene. Benzene is actually a very interesting compound, and it's used a lot in pharmaceutical drugs and a lot in organic chemistry, but it's also by itself, it's incredibly flammable and is a strong carcinogen. So as we can see here, we draw all the carbon atoms individually and all the hydrogen atoms individually. Well, with larger organic molecules, that will eventually become tedious, and it won't really be effective. I mean, yeah, we'll know what it means, but isn't there a way, like a language, that we could simplify it into? Well, yeah, yes there is. Now, if you account back to Vesper theory, that's the theory that all electrons and bonds basically have a relationship with each other. So if we have H2O, let's write an oxygen and 2 hydrogens down here. The reason why this is a bent molecule, why it has this bent boomerang kind of shape, is because up here there are 2 pairs of already paired electrons, really. And down here, this represents 2 electrons. 2 electrons. So this makes an octet rule, and hydrogen not needing a full octet, only needs 2 electrons in its valence shell, makes a full bond, so it's stable. So because these are up here, this negative force repels these negative forces. That's just how magnetism works. So if we go back to looking at this butane molecule, we'll see that the carbon is just kind of in a straight line. That's not actually how it bonds. What it really would look like is more like a carbon, 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 carbon. And then I'm not going to draw the hydrogens because you know they're there. But this is the basis of a bond line structure. Let's get rid of that, actually. Let's get rid of the carbons. Let's make it even more simpler. Let's just make it that. 3 simple lines. These 3 simple lines are bond line structures. This is what a bond line structure is. Each one of these single lines represents 1 bond. Just 1 bond. And at each one of these vertices, it is assumed that there's just a carbon atom. If it were any other atom, you would put that there. You would, if it was a nitrogen atom, instead of just nothing at this vertex, you would put an N. And we don't write the hydrogen atoms because those are just assumed to be there. If there's nothing there at the end, it is assumed to be fully bonded with hydrogen. So if we were to write this again, we would see carbon, 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 carbon. Well, carbon can make 4 bonds. This carbon down here only has made 1 bond. So it must be bonded to 3 other hydrogen atoms. And since we don't write those, it is just assumed that it is bonded to those 3 hydrogen atoms. Over here, this is only 2 bonds. So it must bond to 2 other hydrogen atoms. Down here, same thing. And over here, same exact thing. Now let's take a look at our pal benzene down here. How would you guess we would write this? Well, I'll tell you. First, we would just write that hexagonal ring, and I am not an artist, so excuse my writing. And you see here, these 2 lines, these represent double bonds. And this makes sense because this carbon atom has 4 bonds, and so does this carbon atom. It also has 4 bonds. So the way that we would write a double bond in a bond line structure is just simply the same exact way. We would just write those bonds, and since the hydrogen atoms are around the side, here, 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 and here, we just don't write them. They're assumed to be there. Now, I want to see if we can take an actual compound, a bond line structure, and write it as a general form. So let's take this hexagon. What is it? Well, it's not benzene because it doesn't have these double bonds. So if we look back at this and see that at each one of the vertices there's a carbon bond, we can then assume that at each one of these vertices there's another carbon bond. So that must be C, 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 and C. Boom, 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 boom. And also, because carbon makes the 4 bonds, we could say hydrogen, hydrogen, all the way around. I'm not going to write it all out because that'll just take too much time. And because it takes too much time is exactly why we write bond line structures. So thank you for joining me today, and I hope that this video has taught you how to read basic bond line structures and how to interpret bond line structures into normal, basically Lewis diagrams. So thank you for watching. If you liked it, leave a like. If you want to see more, please leave comments below, subscribe, and I will answer any questions that you have in the future. Thank you for watching.